Hello, and welcome to the Industry 4.0 Monday live stream. I'd like to wish everyone a good local time. This is Women in Manufacturing for the Industry 4.0 Club, a weekly conversation on topics around Industry 4.0 with a focus on tech and manufacturing. In this space, we discuss the perspectives and challenges of women at work and at home. Our topic of discussion for today is titled Semiconductors, Balance versus Resilience. I'm Carol Mitchellin, an Industry 4.0 Club co-founder. For over 5 years, I've been creating content for Industry 4.0 adoption in manufacturing. When I'm not supporting my fellow co-founders, I'm a content marketing specialist at Raven AI, where we help manufacturers engage operators to provide meaningful human context on the shop floor. First, I'd like to introduce my co-host and fellow co-founder, Grace Donovan. Hi, Grace.
Good morning, good afternoon, depending on where you're joining us. Thank you, Carol. I am Grace Donovan. I am a fellow Industry 4.0 Club founder, and then kind of my typical 9 to 5 is working for Endonics. We're based here in Detroit. We are a startup focused on serving manufacturers and promoting shop floor engagement kind of at the human perspective, similar to Raven. So thanks so much. And Angela, thank you so much for being here with us today. Again, we're so excited to have you back.
Thank you, Grace. It's my pleasure to be here.
Yes, I'm going to formally introduce you, Angela. You were the founder of Thurman Co. And you're joining us from Texas today, is that correct?
That's correct.
We appreciate you taking time to be with us. Thanks.
Thank you.
All right, so just to get started, Angela, and this is going to be our first question. We're going to also make you the star of the show here. There we go.
Okay.
All right. So I know you've been with us once before, but for those who are tuning in for the first time or meeting you for the first time, could you let us know a little bit about you and give us an idea of, where you are today and what is the journey that took you there?
Okay. Certainly, Grace. So I'm an electrical engineer, and I took a materials science course as a part of my university studies. And then the summer after graduation, I did an internship at a company in Northeast Oklahoma that produced semiconductor grade silicon and germanium. And I worked for Dr. Jeroy Richter, who ran the single crystal lab. And I helped him to collect data for resistivity studies, which then went into the company's publications, sales materials, and just general knowledge, I think different types of publications about the materials that the company produced. And today I own a consulting firm here in Houston that offers solutions for small to medium-sized organizations that need assistance with technical programs, program management, contract management, and supply chain management.
Excellent. Thank you.
Thank you, Angela. I have a quick question. When you were doing your internship, what was the sense of the semiconductor business that at that time?
At that time? Well, semiconductor businesses is always growing as our world becomes more and more digital. So this was back in the late 80s. And so even then, was very, very busy. And now it's even more so because everything in our lives has become more digital. You think about all the things that we have today that we didn't have 30 years ago, like cell phones and all of the digital devices that we have in our homes, like personal computers, and even on your cars, all of the digital tech tools that are on your cars. Those things didn't exist 30 years ago. And all of that is run with semiconductors.
Thanks for giving us some context to that.
Sure.
Now, when we reconnected recently, Angela, and one of the things on your radar was the semiconductor supply chain and the delays we often are seeing in the news. And it's not something that you wanted to put off. You really wanted to have this discussion sooner than later. And maybe at a high level, if you could give us a brief update on the main issues that are top of mind right now, what's going on, and which industries are heavily impacted.
Okay, yeah. So the main issues these are things that we're all familiar with at this point. It's supply chain delay. So this is something that has just continued to have a snowball effect, and it just continues to run downhill. In the case of semiconductors, the foundries that produce the materials that go into the finished goods they're not able to obtain the raw materials that they need. And they're also unable to get other types of resources that they need. And those could be the large equipment to grow the semiconductor materials into usable forms, testing and machining equipment, or simply the skilled resources that they need.
So there you mentioned, two things. Like one is the material. So foundries being able to get the material that they need to then produce this. And then the delays, right? So if there is that material, it's taking a really long time to get there. Can we first start with semiconductor materials and the supply issues with them?
Okay. Maybe we should start with just some basic semiconductor 101. And let's start with defining what is a semiconductor. So a semiconductor is a material that has a resistivity, or the property of a material to resist the flow of an electrical current. And that's between 10 to the minus 3 and 10 to the 6 ohm centimeters. And some elements are naturally semiconductors, such as silicon and germanium. And some elements are naturally conductors, like copper and nickel, platinum, gold, and silver. Some of the familiar precious metals those are conductors. Those are good conductors. So these elements that you see on the chart in front of you, those are what we classify as the semiconductors. So you have insulators, semiconductors, and then conductors. So then you also have like the compounds: gallium arsenide, gallium phosphide, silicon carbide, and many, many others. Those can be created to form semiconductors. And then the performance of a semiconductor is also heavily affected by the introduction of trace amounts of another element called dopants. So sometimes you could introduce to germanium, you might introduce indium to make a positive or p-type semiconductor, or to make it more n-type, you might introduce arsenic. And so that's also taken into calculation. So these materials are all crystalline, inorganic solids, sometimes called the metalloids. And it is the electrons in their outer valence shells that create their semiconductor properties. So here, this chart shows you how the semiconductors are grouped on the chart, the elements, the chart of the periodic table.
So just to quickly kind of interject, and so I think as this chart is kind of showing us, like semiconductors are mentioned in whites, what we saw kind of in the middle of the previous chart.
Mhm.
And then when you mention the introduction of dopants, is that really kind of combining conductors and insulators to then kind of reach that happy like middle ground?
It's to add, it's to either add additional free electrons or to remove some existing free electrons. So if you add arsenic to germanium, you're going to use up, you're going to, so it currently has 4 free electrons. If you add arsenic, that's going to use up 1 free electron and make it more N-type. If you add gallium, that's going to add a free electron and make it more P-type. Does that make sense? If you
Yes. So when you say N or P-type, could you just clarify then what we're referring to there?
N is negative and P is positive. So P would have, yeah. So P would be missing an electron, and N would have an additional electron.
I see. Got it. Thank you.
Sure.
This is really absolutely like a master class in semiconductors. So thank you.
I had to review a little bit of chemistry.
I actually maybe one of the few people that graduated high school without taking chemistry. I somehow got around it.
So that's germanium and silicon are probably 2 of the most common semiconductors, but there are many, many combinations or compounds that are also created to be semiconductors as well.
Yeah, I think silicon is I think what most folks are, passingly familiar with as being associated with semiconductors and chips.
Yes. Later in my career, I went back to work for that same company. And after I had worked for them for a few months, like I was a sales engineer, so I was selling this stuff every day. And after I had worked for them for a few months, I could not say the word geranium, the little red flower.
Oh, yep.
Because I said geranium, day after day after day.
I feel like people would kind of understand you anyway. If you're at Home Depot talking about germanium, like they're probably going to understand that you're referring to the flower.
Exactly.
Excuse me.
Okay, so silicon it's by far the most widely used semiconductor material, and largely that's due to the fact that it is so widely available. It's easy to fabricate. It's got excellent electrical and mechanical properties, and silicon is the second most abundant element on Earth after oxygen. In fact, nearly 80% of the world's silicon stores are controlled by China. So regardless of whether the semiconductor is silicon, germanium, or some compound to be used for integrated circuits that go into all the goods that we know and want, these semiconductor materials must be very highly purified, typically through the growth of new crystals from crushed material that is melted down in a foundry.
Okay, so now we've gotten to the foundry element, right?
Yes.
So how does getting this, so let's dive into how we get this material then to the foundries and what are some of the delays involved. So yeah, as Carol has the slide up, we're going to switch to the foundries here.
So even though the silicon is so abundant, it has to be mined and extricated from the surrounding material before it can be processed into a semiconductor wafer. And since China controls so much of the silicon market and the restrictions that we have in place today, it is very difficult for the foundries to obtain the raw materials that they need. And so this slide shows you a 2020 report of the foundries, and you can see that by and large they are in Asia. I think that a lot of people in the U.S. would be surprised that Texas Instruments doesn't even make the list of top 10. And you can see that if the foundries can't get the raw material that they need, then productions of the wafer slows down or even comes to a halt. So this means no more integrated circuits, no more printed circuit boards, no more power supplies, and all those other products that rely on semiconductors. And all of those products then mean that the entire production of electronics, all those businesses are impacted.
So I think, and we were kind of discussing this in our kind of prep session, but kind of the question around, why is there such a concentration of this material if it is the most abundant or like the second most abundant element on Earth? Like, why does China have so much concentration of it? And you had a great response to that.
So silicon, if you think about silicon being available like anywhere there's sand, basically, and China has a great store of it because of the Gobi Desert. But then you think about all the places that there are other large concentrations of sand, like the Middle East. Well, why can't we get the stores of silicon from the Middle East? Well, we probably could if they were interested in becoming exporters of silicon. But they have other interests, oil interests, for example. So they're not in the silicon business right now. Maybe we should help get them interested in becoming exporters of silicon.
Yeah, and I think just doing like a little research as well. I know this is like an industry as well with like a lot of barriers to entry. Certainly being a provider of this commodity, I think people would welcome that, especially with the shortages that we've seen. But it is certainly a tough industry to get into. It's got a lot of like very tightly closed doors. But just even being here in Detroit, like, the auto capital of the U.S., and there's just lots full of cars that are waiting for chips. It's like been a very common sight over the past 2 years.
Yes. If we were to go to a car lot, even here in Houston, and it had more than 100 cars, I'd be shocked. And a lot of it has to do with the inability to get the semiconductor-based products that are needed in auto manufacturing right now.
Yeah.
Okay. Thanks, Grace and Angela. I wanted to steer back to the title of our conversation today: balance versus resilience. And the topic actually came from an interview recently with the CEO of Intel, and he was talking about semiconductor delays and specifically about the chip bill. And for anyone who wants to see that interview, we have the link in the comments for the event. But I wanted to know, Angela, what your thoughts were on the interview. If you agree with a balanced approach is maybe more ideal than a resilient approach to the supply chain. Well, what were your first thoughts?
Well, I thought that was a really great interview, and it really emphasized how the semiconductor industry in our economy, and also how it's so important to our national security, which I don't think a lot of people think about that. But I'm not sure that I agree with his analysis and the description of a balanced supply chain. Based on some of the interactions that I've had, the information that I've received in an industry forum that I take part in, I believe that we can expect some of these supply chain issues to last through 2024 and possibly into 2025. So I think that it would be ideal to have a balanced supply chain. I think that that's a good term, but I don't think we're anywhere close to that. And I think that his representation that we could achieve a balanced supply chain within 18 months is a little bit optimistic. And maybe we'll just have to wait and see, time will tell. But I do think it's important to realize that some of their conclusions were based on the fact that we have to get funding. The CHIPS Act has to pass, and then you have to think about the conditions for these factories. So this is a lot of capital expenditure. The equipment to develop or to grow these crystals and create the wafers that become the chips. This is very capital intensive, and this is in a clean room environment.
Mhm.
So you just don't throw up these buildings in 6 months and start production. That doesn't happen. So
Now,
the construction of these plants is going to take a very long time. Once you've got money and permits and you actually have equipment, it still takes a long time.
now he mentioned the CEO mentioned that the bill was really necessary for them to be competitive.
I agree. Yeah.
That it can be done without it, but they wouldn't be able to be competitive on a global scale without that help.
Mm-hmm.
Okay. Now, do you think it's too late to talk about mitigating risk in the supply chain, or are there still some things that can be done?
I think that there are some things that can be done. I think that there are some things that have to be done, or else we're going to continue down a downward spiral, which we don't want. Um, so yes, we definitely need to start work now so that it doesn't continue to get worse.
Now, this is similar to some news that you shared on LinkedIn last week.
Mm-hmm.
Was the news from the state of Texas about a semiconductor company out of Taiwan, Hsinchu,
Mm-hmm.
and that they have plans to build a silicon wafer factory in Sherman, Texas.
Yes.
And I guess to put this into perspective, they're planning to build a $3.2 million square foot silicon wafer factory. And they're expecting this to be one of the largest facilities in the world, the largest in the US and one of the largest in the world. Did this announcement catch you off guard?
Not really. I mean, I'm very happy for the decision to bring that plant to Texas, and especially just to build a plant at all. But it's a great decision to build it in the U.S. And we and Texas has been leading an effort to bring more high tech to Texas, and so there have been a lot of recent announcements for high tech manufacturing in the state of Texas, with the recent Tesla plant going into Austin, and a lot of other plants going up in our state. So I'm not surprised that they decided to bring it to Texas. We already have the TI plant, which is going to. This new plant is actually very, very near existing Texas Instruments plants. So it'll draw on the existing workforce, and that'll be very good for the region.
Now, just as like a quick clarifier, so is this factory, does that also include a foundry?
Not from what I can tell,
Okay.
but I don't know. I haven't investigated that fully.
Yeah, I think I need to as well, but I'm just kind of curious, thinking of, how vertically integrated is a lot of this? Do we have foundries in the same places as we have the factories?
Yep.
Or, is there some separation sometimes?
Since this one is going to be so large, I wouldn't be surprised if it does include a foundry.
Okay. Yeah, and hopefully the restrictions then will be by the time this is up and running too, something like clearly, we have, an Asian supplier here in the US working, and hopefully the restrictions won't continue to put like pressure on that production and on that supply chain.
Yes, absolutely.
I'm wondering about the workforce, if the workforce on the state level and the national level can support technical roles like this.
That is an excellent question. Yes. I think that we'll get there. Yeah. I think I know that the Texas Workforce Commission has an excellent history and for creating programs specifically for this kind of thing, and they've got the lead time to begin to train upskill the workforce that we have. So,
as you mentioned, like Texas Instruments is there, so there is already some kind of concentration or base, or at least like relative like regional familiarity with this industry, right?
Yes, absolutely.
Geography in this day and age, geography still very much matters. Like how talent is distributed, but as you mentioned, like there's plenty of lead time, and I think this is certainly something. I think we've been talking about like a chip shortage for quite a while now, and it's something that I think is continually putting a strain on the industry. It's certainly a great indicator of overall economic health and how things are going forward. So this is something that has really come to the forefront of people's consciousness, and I think that also that awareness will certainly help kind of funnel the talent that we need. So is my like optimistic assumption.
But one plant in Texas is not going to solve all of our problems.
No, it won't. But it's a support.
Do you think the materials shortages will be resolved by then? And if not, do you think that could have any impact on the production levels?
That's a really good question. I pray that they'll be solved, but we've got to look for alternate sources. We can't have China control 80% of the silicon pipeline, if you will. We've got to find alternate sources.
Yeah, sounds like a whole chapter in and of itself. Really getting into geopolitics there as well.
Yes, we really are.
So, kind of also thinking of, around the title of this room, balance versus resilience. I think, one thing as we look at, and this kind of brings us up because we were also discussing kind of the labor pool that we have to address this industry. And a couple weeks ago, as women in manufacturing, we've had this discussion a fair amount, but we reviewed a recent report from Deloitte that really focused on the workforce, specifically women. And one of the stats that we reviewed that really has like stuck with us is that 1/3 of women who have taken time off work because of mental health challenges, so like 30% or 33% have done that, but very few, only about 43% feel comfortable like talking about these challenges in the workplace, especially when it comes to like balancing workload, and then how resilient can you really be after so many years and like a lot of stresses. And so we were focusing on burnout. And there's definitely a lot going on in the supply chain, and we're all very visible with multiple projects. So I just see a lot of like different ways that these two topics connect, one being very much an industrial challenge, and then one being like a challenge kind of on the personal side. So how do you work on maintaining a work-life balance for yourself and those around you, kind of like from where you're sitting?
Well, thank you for asking that, Grace. So this is very important to me. And I have been working from home for over 6 years before the pandemic even started. So I didn't
Trailblazer.
yeah, I didn't feel like I was isolated or, that was a big change for me when the pandemic did start. And that was actually, really good for me. But um, it just felt like I was doing more of the same. But then I do make time for myself to take part in a women's group uh, um, for my own mental health and self-care, and I do that every week. And then I also make sure I take time to connect with a couple of really good friends virtually every couple of weeks, just because we're geographically distanced. And then I also have my volunteer work with the Texas chapter of Women in Manufacturing, and that's where I get to give back to my community that's so important to me. And that's a really big part of what helps keep me grounded. And then I do make sure that I take some time, after work, just to decompress and again, self-care, whether it's reading or, out on my deck or, with my dogs or whatever. But I have to have some alone time to just decompress, and spending time, going out with friends for dinner or just doing something social whenever I can do that too. And then I also like to plan, usually about once a month, something big to look forward to, whether it's a business trip or a trip with friends, which, living in Houston and going to the beach is a big thing. Something like that. So every month I have something that's a big, looking forward to this kind of thing.
Yeah, that's, I think we've had this discussion with a lot of women, and it's always, I think, fantastic to hear about how, like, different ways that we're coping with, like, building this resilience, right? Because it's certainly important for, I think us as women, and then us as a workforce in general. And because it's been like a very straining time, I think, not only like, knowing all the challenges that have like suddenly popped up and navigating that, like whether that's with your business, just kind of, moving through the world with a lot of these challenges. It's really important to, like, again, we're thinking a lot about resilience of our systems, how things are balanced or how things are imbalanced at a global scale. And sometimes it's really, not sometimes, it's often very necessary to like take a step back and realize, we can certainly change the world and have an impact, but we have to make sure that, like, it's going to be sustainable for us to do that. And a huge part of that is building that personal resilience. So I think, speaking of things that you're looking forward to, this is maybe a couple months out, but you're sponsoring an aerospace summit in September. And can you share a little bit about, like, what's your role going to be in that? Like, this is a big upcoming event, and tell us a little bit more about how Thurman Co. is involved in that as well.
Sure. So I've been a member of Leading Ladies of Aerospace, which is a virtual it's an online group that was founded by Fiona McKay and then her right hand lady, Joanna Boatwright, practically since its inception. And I sponsored the summit last year and just was thrilled with the outcome. And so it's a virtual event again, coming up in September. And I'm just delighted to sponsor the event again. Fiona always provides so much value to her members. And there will be a number of speakers. Everyone just will get so much out of this event. I'm just delighted to be a part of the organization and to do whatever I can to sponsor and bring attention to women in aerospace. So I'm very happy to be a part of that. And,
That's awesome. Sorry, go ahead. You were going to say
I was
something
just
else?
going to say, so Leading Ladies of Aerospace also has monthly events like leadership labs, mastermind groups, and other things like that. And so I was really delighted that Fiona asked me to be a panelist at an upcoming event. So looking forward to that too.
Yeah, I was going to ask you if you could share a little bit more. So for those in the audience that, are involved in the aerospace industry that are also women, how is this similar to women in manufacturing, like that you're a part of in Texas? And then how is it really different specifically for women in aerospace? Like, just love to learn a little bit more about it because I wasn't familiar about it or with it until today. So.
Well, it's a virtual group. It's a LinkedIn group called Leading Ladies of Aerospace. And so everything is done virtually, and it's you just send in, you just request to join the group, and all the content is posted within LinkedIn.
Yeah.
So yeah.
Excellent. Well, definitely would encourage anyone to go check that out. We'll follow up with, links and everything in the post. And then if folks want to attend this aerospace summit, would they go to the LinkedIn page to register?
Absolutely. Yes.
Okay.
You could get the information there. Yes.
Okay. Great. We want to make sure that we're pointing people in the right direction because these communities can have like such a, a positive impact. And I speak from my own experience just with the Industry 4.0 Club and like how it has really, especially in like the remote environments where we're often like physically distant, I have had the good luck now that, we're beginning to go back into person to meet a lot of my fellow co-founders. I have yet to meet Carol. That is still coming in person, of course, right? But these online communities have been just really fantastic. And so just would encourage everyone to like reach out, especially if you're feeling like alone and isolated. Like it can be a real fantastic resource, especially with it's like related to industry. And then again, with a focus on like, supporting fellow women. So I think that's really fantastic. So thank you very much for sharing that.
Of course.
So, Angela, I think you've done this before with us. Usually near the end of one of our conversations, we do a recap and have some final thoughts and takeaways to share with each other and those who are watching or listening in. And we'll give you the last word. So maybe Grace, if you could give us your final thoughts.
So just as like a quick, takeaway, I came into this also, not knowing a whole bunch about semiconductors. So Angela, thank you for this masterclass. It has been, very interesting. Certainly learned a lot more about, I think something that a lot of folks are maybe like passingly familiar with, but as soon as you're pressed on like, tell me a little bit more about that, everyone draws a blank, or at least I would. So I think it's what really, really stood out for me, I think, is how pervasive this really is, and just learning a little bit more about the intricacies, there we go, of the supply chain of this market, what the dynamics are, how tightly, like the big barriers to entry that it has, some of the, again, the challenges around kind of getting that material, why, even if it is so common, is it hard to come by? And then I think, I would certainly encourage everyone to go, do some additional research around the CHIPS bill that's currently being debated right now. I think this is also excellent additional context for us to understand a little bit more about the consequences of that proposed legislation here in the US. So thank you very much for that. And yeah, I think that's my big takeaway is just absorbing a lot of new information around semiconductors and their importance and how that sausage is made.
That's amazing, Grace. Thanks very much for that takeaway. I think mine is a lot like yours. It really brings this conversation has really brought it to my attention more, and like there's all different kinds of manufacturing, but really when we're diving into advanced manufacturing, I was shocked at how small we're talking about here. And that's not really something we got into yet, but
I'm gonna start taking today, apart my phone.
But definitely, like we're talking about really, really small stuff. And so that was a big shock. But thanks for bringing this, the supply chain issues and the delays to our attention, and definitely we'll look into peeling off the layers of semiconductors and wafers and chips, and you definitely inspired me. So that's my takeaway, and we'll leave the last word with you, Angela.
There's one of the things that I would like to leave you and the audience with is this technology was invented in the United States.
Mm-hmm.
And
it's like the origin of Silicon Valley, right? You know?
Well, not just Silicon Valley.
Not quite, but like.
Yeah. I mean, the transistor was invented in the United States. It's as if we didn't value our own intellectual property enough, and we lost control, and now we don't have enough manufacturing facilities to meet our own demand, and we don't have enough skilled labor, and that's sad. It's really sad. So I would so much like to see this technology brought back to the United States, and for us to become a leader in the technology again. And so that's one of the reasons why I hope to see the CHIPS bill passed, so that we'll see more and more growth in something that is so fundamental to so much of what we use every day.
Mm-hmm.
There's almost nothing I can touch here at my desk that doesn't have semiconductors in it. And it would be really heartwarming to see this technology restored to the U.S.
Yeah, I really liked the way you framed that as well. Kind of, what happens when the intellectual property kind of is outsourced, and then when you need it back, it's very difficult to kind of bring that back, and all the consequences that has. So that that's very helpful, kind of, I think, tying a bow around the discussion that we've had today. So thank you.
And thank you again for having me on the show. It's been a pleasure. And I kind of got to take a little walk down memory lane. So
anytime, you're welcome always. It's such a pleasure to have you.
Yes, Angela, we appreciate your continued interest in supporting women in manufacturing and women in leadership, and
of course,
sharing your experience in supply chain is valuable for all of us. And I'm going to do a little bit of promotion for the Industry 4.0 Club. We have conversations like this. If you'd like to hear more, on Mondays through Thursdays on LinkedIn Live. Sometimes we're on Clubhouse, and our conversations usually start at 12:30 p.m. We are currently on our summer schedule, so we encourage you to check in our LinkedIn page for events and event notices, and plan to attend so you can receive a notice when we're starting. That way it'll be easier to keep track. And thanks everyone for being with us today, Grace and Angela. And I'd like to close and wish everyone a good day. Thank you.
Have a good day.
Thank you.